Okay, let's get into the Logger Pro part. So I'm going to go through file by file, and we're going to look at Logger Pro, and I'm going to show you guys how to do different things, so how to analyze different parts of your graphs. You're going to watch me analyze my graphs, and then you're going to do the exact same thing on your graph, and the video is going to pause at different points for you to try this stuff on your graph. So whenever it pauses, that means that it's time for you to go get your Logger Pro graph out and try whatever I did. Now you can rewind the video if you want um, to 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 watch what I did again if if you forget or if you're unsure. All right, so first let's start off with constant velocity. So I've got my constant velocity here. I'm going to go ahead and open it up, and my constant velocity looks something like this. So let's focus on the top one first. So everybody should have a constant velocity graph that looks something like this. I've got an uphill line. It's nice and linear. It's nice and straight. You shouldn't have any stray dots around. If you do have some stray dots around, you need to delete those. If you want to delete a dot, I'll show you. Just highlight it. So see how I highlighted that dot right there? I just kind of drew, I highlighted the area where that dot is. Go to Edit and click on Strike Through Data Cells. I'm not going to do it because I don't want to lose that dot. But you can strike through data cells. Actually, here, I'll do it. Okay, so it deleted that dot. If I want it back, I'm just going to hit Command Z, which is the undo. You could also go to Edit, Undo. All right, so the first thing that I'm going to do is I'm going to show you guys how to find the slope. Now, you guys have done a bunch of stuff where you do rise and run, and you do it by hand and all that. The really great thing about Logger Pro is we don't have to do it by hand. So make sure that you're clicked on this graph. And then all I'm going to do is I'm simply going to click on this button here. So I'll let my mouse hover over it. See how it says linear fit? So the linear fit button is the button that we want. So I'm going to click on that right there. I click on it, and notice that it draws a line of best fit right over the top of my dots. And it actually has a mathematical equation that takes all those data points, and it figures out the very best line to fit all of them. Now I'll take this and I'm going to make let's see. I'll make the font a little bit bigger so we can see it. There we go. Yours, you don't have to make the font bigger if you don't want to, but I did. All right, so if we look at the stuff that we can see here, you guys are just about to start doing linear functions in algebra if you haven't already. So this is giving me my different information. Notice it gives me M, which is also slope. It gives me the y-intercept. It gives me the correlation. You don't know what that is. I don't even know what the RMSE is. That's interesting. Some standard error maybe? I don't know. But what we're really interested on right now is the slope. So I can't highlight it. Can I highlight it? Nope. All right, so the slope for me is 2.034 meters per second. So what that means is that on my analysis of my runner, which is not the same as all of you guys's, I found that runner was running 2.034 meters per second. So what you're going to do is you're going to figure out the exact same thing for your runner. It should not be the exact same number, but depending on who you did, it's probably pretty close to that. So go ahead and do that now. Okay, now the other thing that I can do on my graph is notice that I've got this graph down here. Now what I did is you can double click or two finger click, doesn't really matter, to open up the options box. Actually, if you were to two finger click, you would get graph options, or you can double click and get graph options. Now over here on the left side, what I did was I changed this checkbox right here from auto scale to manual. So notice if it's auto scale, it'll look something like that. But if I change it to manual, I can set it myself. And in class, I set it to 0 and 10. So remember that zooms out a little bit. It was zoomed in really close. When I zoom out, I see this nice straight line. Now what's nice about this line is I can actually click on the linear fit button again. And what it does is it draws that straight line right through the data. Now I'm going to go here And I'm going to make it bigger again so that you guys can see it. Again, on yours, you don't have to make it bigger. This is just helping for video purposes. But I want you to notice something. So the slope is really little. So 0.04 is very, very small. And that makes sense because it should be flat. So flat would be 0, and it's really close to flat. So that's good. Now, the other thing I want you to notice is that my y-intercept is actually 2.458. And notice that's meters per second. So this straight line where it touches over here, where it touches the y-intercept, is pretty close to the velocity that I calculated up here. And that makes sense. The closer this y-intercept is to this number up here, the better our data was. And in this instance, it's Amari, so he's actually slowing down a little bit. That messes it up some, but that's okay. So you're going to go and you're going to record the y-intercept right here. That just means where does your line cross the y-axis? That's this little point right here. You're going to record the y-intercept for your graph now. Okay, and that's all we're going to do for this one right here. So I'm going to go ahead and I will quit Logger Pro. Sure, we can save the stuff that I put on there. All right, I'm going to go on to speeding up and slowing down. We're going to skip over speeding up because speeding up and slowing down kind of gives us the same information as speeding up. So to me, this is a little bit more useful. Oops, I got a couple things on there we're going to get rid of. All right. All right, so speeding up and slowing down. There's a couple things I want to show you that you can figure out using this graph. Now, I think most of us have figured out that when the ball's speeding up, we see the ball going up. It looks like it's going up on the graph, and that's fine. That makes sense. And then it hits some point where it doesn't go up anymore, and it starts to come down. So the first thing I want to think about is this spot right here at the very, very top. What does that mean exactly? And I've got a tool, so when I click on the graph, one of these tools up here I can use, and it's going to be this one right here, Examine. See how it's the line that crosses through the curve? The Examine button, when I click on it, what it lets me do is I can take a close look at any of the points and see exactly where that point is at. So I'm going to go ahead and make that a little bit bigger so we can see it on the video. Okay, there we go. All right, so I can look and I can see, okay, well, at the very beginning, so the height here is y. So notice the ball, let's see, perfect. All right, so the ball is not very high. It's showing that the ball is 0.3787 meters. So it hasn't even gone a full meter from my hands, like a third of a meter, and that looks like it's about right. As I continue up here, notice that the ball is getting higher now, right? So now, as the ball is way up over my head, now it's getting closer, almost 2 meters from my hands, and that looks about right. 2 meters would be like 6 feet, so it's definitely farther up out of my hands. Now, what I want you guys to look at is this very top dot right here. It's the highest. So notice that the ball is now at its highest point that we recorded. It's way up near the rafters. And I see that the highest point I recorded was 2.444 meters. So that's how high I threw this ball from the starting point where it left my hands. It doesn't mean that that's not from the floor. That's just from where it left my hands. So I'm going to record that as my highest point. Now you're going to go on and you're going to record your highest point based on what you saw on your graph. Okay, so it's not going to be 2.44. Whatever you have for your graph. Okay, now what I want to look at is there's another tool I can use. Well, what's that? I don't want that. All right. So the next tool that I want you guys to try out is this one right here. Now see, I've got a curve and a little line that touches the edge of the curve. That's called tangent. So go ahead and click on that. Now what's happening here, and again I'll make the font bigger. We'll pop it up to 18 so you guys can see it. There we go. All right, so at different times, what it's going to tell me is the slope. So notice I start off steep at 5.763 meters per second, and it's going to gradually get less steep. So 4.25, 3.63, 3.0. Eventually, as it gets lower and lower, it gets almost down to 0. So 0.199. And then it's going to start to go the other way. So it's going to keep going down, and it's actually going to go negative slope. All right? But as it gets negative, notice that even though that number is negative, the total value, the absolute value, is getting bigger. So 2.781 is bigger, 3.39 is bigger. So the number is actually getting bigger even though it's negative. And so what that means, guys, is that right here, when that ball first leaves my hand, that's the fastest it goes on the way up. And all it does is it slows down. As it gets less and less steep, it gets slower and slower and slower. So up here, it's at its slowest point, 0.199. Now, as it goes down, and again, it gets steeper, right? So it's flat up top. And as it gets steeper on the way down, notice that it's getting faster and faster and faster. 3.96 is faster. 4.4 is even faster than that. And then my fastest is 5.49. So what you guys are going to do is you're going to record for me the speed at the very beginning. Right? So this question is going to be the speed at the very beginning. My speed is 5.763 meters per second. Now I want you to go all the way over and record the speed at the end. Negative 5.499 meters per second. Now here's the reason it's negative. When we record velocity, positive means it's going in the object is moving in a positive direction. Negative means the object is moving in a negative direction. So over here, my slopes are positive. That's because the ball's going up. Over here, my slopes are negative. That's because the ball's going down. Listen to that. There might be a question on that. Okay, now let's go down here. And there's one thing we want to do. Now notice again, this is a straight line. Anytime I see a straight line, it makes sense to do a linear fit. So I'm clicked on it. And I'm going to go up to my linear fit button. That's the one where the line is right on top of the curve. And I click it. And what I can see here, I'll make it bigger so you guys can see it too, is it's going to give me all that information again. It gives me a slope. It gives me a y-intercept. It gives me a correlation. Now here I want you to look at the slope. That's important to me. So the slope here is negative 6.952 meters per second per second. Now we'll talk later about whether that's the right number or not. It's not exactly the right number, but I want you to go ahead and record what your slope is. It should be negative, and it should be somewhere close to this, but record what your slope is now. Now one of the questions that was on your sheet is, why does it keep going? When this changes direction up here, why doesn't this one change direction? It just keeps, the line just keeps going down and down and down and down. It seems like it should go down, 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 and then go back up because this one's doing that, right? It's changing direction. Now when we think about this, okay, this is speed, velocity. So here I've got a big positive velocity. That means it's moving fast and it's going up. Now gradually that gets lower and lower and lower as it slows down. So this is showing slowing down. And here is my 0 point right there. That's where it's not moving at all. Now, as it goes below, notice this is 0. As it goes below 0, it's actually speeding up. So even though it looks like it's going down, this speed down here, negative 5.4 or so, is actually faster than this speed up here. So the velocity starts off big and positive and ends up big and negative. So what that means is it's slowing down, slowing down, slowing down, speeding up, speeding up, speeding up as we move along. All right, that's all we're going to do for this one. The last one's going to be changing directions. So I'm going to quit Logger Pro. Sure, we can save. And then let's go to changing directions. This will be the last one, guys. Okay, so within changing directions. Now I see everybody's seen this where we see we've got a straight line where the disc is moving at a constant velocity. It's going to the left. It bounces off the wall and then it goes at a constant velocity back up. Now there's two things that I want you to do. So we're going to use the linear fit for this. But what's cool is we actually can do linear fit for specific sections. So I want to do linear fit, but not for the whole thing, because I've got two different linear sections here. So I'm going to highlight just this front section. So all I do is I just clicked and dragged a little box around it, and I'm going to do my linear fit. So notice what I've got now is I've got a linear fit for this section here. Now I can go in and I can make that bigger so you guys can see that. 18. All right, so I've got a linear fit for the first section, and then I can go and I can highlight the back section and do a second linear fit. So now I've got two different linear fits. I'm going to make that bigger. All right, so one for the downhill part, one for the uphill part. Now, notice that my slope going downhill is negative 1.967. My slope going back up was 1.289. Okay, so I think about 1.96 is faster or steeper than 1.289. So this section here, the beginning section, is faster. As after it bounces off the wall, it's not as steep, so it's slower. The reason for that is that when it hits the wall, it loses some speed. So it loses some of its energy, it loses some speed, it's not quite going as fast. Now when we go down here to the bottom, we're going to do something very, very similar. Now, I've got a flat line down here, right there, and I've got another pretty flat line up here. Again, I want to do linear fit for those two sections. So my linear fit for this flat section down here is going to look like that. Sorry, you guys have to watch me make it bigger over and over and over again. All right, so there's my linear fit for the bottom section. And then I'm going to go highlight the top section as well, and I'm going to do one last linear fit. Appearance. Okay. All right, now, again, what I'm really interested in here is the y-intercept. So my y-intercept for this first part is negative 1.849 meters per second. You'll notice that that number there is really close to this number here, 1.967. Now down here, my y-intercept is 0.05443. And this y-intercept, ooh, interesting. Okay. So that's not exactly what I expected. Oh, wait a minute. No. So the velocity, yes, I got my negative velocity. So really what happens here is that this line tracks all the way down lower than I would have expected, which is fine. 0.05, that doesn't make sense, does it? That's interesting. Well, go ahead and write your y-intercept down. Mine's 0.05443 meters per second. We're going to have to talk more in class about why it's not quite the same as this slope right here. But we do want to go ahead and write it down. We're practicing using the tools of Logger Pro. So the question is going to ask you for this y-intercept and this y-intercept. All right, so guys, that concludes this video. You've been asked a lot of questions along the way. Thank you for sticking with it. And if you're done early, you can work on stuff for other classes.